Da 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 da. If you can't get this tune, then you do not qualify as a fully cultured American. I'm just saying. All right, we are going to talk about the official math definition of r squared, and it's lunchtime for me, so deal with it. Now, the official definition is r squared is the percent of variability in y explained by x, which is probably going to make absolutely no sense to you until after we've done some pictures to help explain it. We got two different zoos here. The Mitai Zoo, and we've got the Yetsat Zoo, which means absolutely nothing. They're nonsense words and are certainly not backwards in any way. So, we have pandas at these zoo. Why pandas? Because pandas are cute, and so we care about them. If pandas were tasty, then maybe this would be a different type of problem. Also turns out I can't eat while recording a video. It does not look good. So, grab my marker. We are going to put dots for the Mitai Zoo. We have pandas that died when they were young, and that's really too bad. And we have pandas that died when they lived about the right age, and that's good. And we have pandas who lived to be way old. And it sounds like a machine gun. Dr. Bieber's office is next door. I always wonder what he thinks when I do this. Let's talk about the Yetsat Zoo. Some of the pandas died when they were very young. Some of the pandas lived to be a reasonable age, and some of them lived to be quite old. This is just to annoy Dr. Bieber. So far, if I asked you to compare these two zoos, you would say, I don't see a whole lot of difference. There's a wide range of lifespan for pandas, and that's true for both of these. So let's add another axis. So we have panda lifespan based on the temperature of the cage that the panda is in. Over here, panda lifespan by the temperature. And what I'm going to do is for each of these dots, I'm going to plot where it was on the temperature scale. If I can stop putting my black marker on the wrong side of the room. Turns out for this guy, the temperature was low. That one, the temperature was kind of high, kind of low, kind of high. These guys here were low. This dot here belonged over there. That dot belonged here. And these dots belonged here. See what I'm doing? I'm just taking the dot and moving it over where it fits according to the temperature, right? And I'm also annoying Dr. Bieber just because it's fun. What do we end up with? Well, we have a regression line that kind of looks like that. As the temperature increases, the panda lifespan also tends to be increasing. On this side, what are we going to do? Oh yeah, you should be jealous of my Stevens hot chocolate. Well, this panda was at this temperature. These pandas were at that temperature. These pandas were over here. These were over here. Those ones were over there. And these pandas were up here. This is kind of therapeutic. If you ever feel frustrated, just start drawing regression dots. Now, do we see a difference between these two zoos? And the answer is yes. Here there was a lot of variability before. There was this much variability before. And then afterwards, thanks to regression, we had less variability. More like that much. So how much of the variability did we lose thanks to temperature? It looks like we lost 30%. That would be r squared. R squared here would be 30%. What about over here? This was all the variability we had. And then thanks to regression, that's how much variability we had after we did our regression. So how much of the variability did we lose? Well, it looks like this is 10% of it. So 90% of our variability is gone. That's an r squared of 90% and a marker that's dying. Okay, so based on the picture, you can see the percent of variability in y that is explained away thanks to x. That is the percent of the variability in panda's lifespan that can be explained by temperature. As r squared gets closer and closer to 1, 100% of the variability goes away. The more those dots follow a straight line. As r squared gets closer to 0, the more those dots are totally spread out. Thanks to x, we didn't lose any variability. It was spread out like this, and it was still spread out like that. Both of these have the same regression line. R squared is not the same as slope. you could have the same r squared with very different slopes. Now, it is true that we could use r squared to test whether there's a relationship. Here the relationship is weaker, here the relationship is stronger, and so we could do a test with r squared, but that's not the way we're going to do our hypothesis test. We're actually going to do a hypothesis test on the slope. But this definition of r squared is something that you are expected to know. And you can be jealous, but this looks a lot better than it tastes. And hot chocolate's a terrible idea in the middle of the summer.